The main presenters today are me, Bradley Anderson, and Yuri. I'm a community manager. I started working with KGB in about July at this capacity. So um, I'm from the US originally. I live in Switzerland for the last 10 years. Currently in the US doing this presentation. And I am a reformed Perl hacker and a reformed technical account manager. So I'll let Yuri introduce himself.
Hi everyone, I'm Yuri. I'm principal solutions architect in Abound. So if you heard about Abound, you probably can imagine that I'm mostly involved in cross-plane related stuff. I'm with Abound for 3 years, but before that, I was lucky to work with wonderful bank of APSA. It's one of the largest South African banks, and that's where we created this project. So I was lucky to be in the circumstances where I had a real business challenge, right? And I was enabled to create this solution, and that we eventually contributed to CNCF. So really excited to be here and take the opportunity to take the project to the next level. Thank you.
All right. And those are Upbound sunglasses I'm wearing in that picture, by the way, because I used to also work at Upbound. Okay, so the agenda is pretty simple. We're going to talk briefly about the motivation behind the project, the background, what it is. Then we'll talk a little bit about the community, what our roadmap, our goals are going to be going forward, where we've been, where we're going, that kind of thing. And then we'll take a bit of a deeper dive into the architecture. At the end, there are some, well, usually you can just push the numbers, but I can't here. So at the end here, I'll just scroll through very quickly. At the end, there are some links, right? So that you can get to some of these things that we're talking about. So our incubation application, project website, the GitHub repo, our biweekly meeting notes. We've had now 61 biweekly meetings as of yesterday. So it's a well-established process at this point. And then links to our social. So as part of community management, we've started to set up things like we've had Slack for a while, but we're starting to set up things like LinkedIn, Twitter, and Medium. There's so far one blog post on Medium, so you can go and take a look at that if you click on the link there. And now I'll scroll back to the beginning. So, all right, does that sound more or less okay? Is that what everybody expects, or good? So background and motivation, we'll go through this relatively quickly, but again, stop me if there's something. So let me move this thing out of the way because all I'm seeing are people. There we go. So as Yuri said, the project started at APSA Bank. So just like everybody has been for the last 10 plus years, moving to the cloud, needed a global load balancing solution. They wanted it based on Kubernetes, right? They have a bunch of different applications geographically dispersed. They want to make sure that people can get to those applications when they need to, right? So same thing as everybody's doing. They found some proprietary solutions like Infoblox, some software, some vendors, but they turned out to be either expensive, complex, not cloud native, or they needed dedicated hardware, or they ran outside of Kubernetes. And there's a link here. There'll be some links throughout that you can look at to the documentation, which will explain these things more in depth once you have the slides. So, but basically, this is the reason that KGB was born. So ABSA decided that they wanted to try to find a solution on their own because none of the existing solutions fit. So the solution basically needed to have no special software or hardware, wanted to rely on open source stuff, wanted to be a CNCF project, didn't want to have any kind of dedicated management cluster so there wouldn't be a single point of failure, and that it had and wanted it to fit in with existing workflows, right? So says here GitOps customized Helm, but you know when you're taking on a new project, there's always some work that you have to do with respect to learning what the new tech stack is and then transforming what you have to meet that new tech stack. Well, that requires a lot of downtime. It requires a lot of cycles that people may or may not have the ability to afford. So why not make part of that transformation something that you already know so it's easier? So the goal was basically all of these things were to service the goal of having something which was agnostic to environment, to cloud, something which is easily pluggable and Kubernetes native. So people know, hey, I've got a CRD, I can create something just like this, just like I'm doing normally, and put it into my existing GitOps workflow. Does that make sense? All right. So KGB is, as I said, it's open source. It's implemented using Kubernetes operator pattern. So there's a KGB Kubernetes operator sitting in the cluster, and it's watching applications and it's updating DNS so that when a request comes in, it knows which cluster that it can go to, for example. There is a single CRD called GSLB, which enables this global load balancing. If you click on this link, it takes you to the code. I won't show that now. But it is vendor neutral, right? This is one of the things that we have to make sure of to even be at this point, to be at the incubating stage. So every meeting that we have is on, the Linux Foundation Zoom account, for example. We're not tied to Upbound or ABSA anymore, for example, companies that you've heard already. So CNCF Sandbox project working on incubating. So as far as we know, it's the only cloud native Kubernetes global load balancer at the moment. So some key differentiators are, as I said, it's configured with a single CRD. It provides independent global service load balancing capability to any ingress or service. Said already, there's no dedicated management cluster, so that means there's no single point of failure, right? And I think this is one of the scenarios that Yuri can show if interested when he gets into his part. If there's, there is a fallback scenario, right? So if one cluster is not available, you'll go on to another cluster, right? This is a typical kind of things for load balancers. So load balancing uses time-proof DNS. And as I said already, it's Kubernetes native app health checks that use things like liveness and readiness probes. So everything is architected in a way that you're already familiar with, so that it's easy to pick it up, it's easy to use it, and it's all toward sort of commoditizing global service load balancing for Kubernetes. Let me see. I can't see anybody, so just tell me if tell me if you have any questions. So that's a basic overview of what the background is, the motivation behind the project, a very, very high level architectural overview. And now I'll talk about the community a little bit. So we've got 5 public adopters right now. We know there's more adopters than that, but if you've done something like this before, it's a process to get everybody who's adopting it to sign on to the adopters.md file, right? So but there's some big companies, right? Some nice big companies here like ABSA, Millennium, Open Systems, FE Code. So 2-time finalists for the CNCF Security Slam, perfect CLO monitor score, as you can see over there. And we have maintainers right now from some of the same companies. So ABSA, Upbound, Kedify, Accenture, and contributors from Millennium BCP. I think one of those folks is here today for example, and one of the folks from Open Systems is here today. We started the community management practice, as I said, I think around July. The early goals are really just to spread awareness and to get incubating, to start going through this process, right? So to this point, as I said earlier, we've done some things like create some socials. We've started changing how we do the community meetings. We've started collecting some vanity metrics, things like what you see in the statistics spot there, like we have 922 GitHub stars now, 98 forks of the project. It's growing. You can click on this link and you'll see the GitHub star activity over time. We've got 106 members in Slack at the moment. As I said, we've had a bunch of community meetings, and Twitter, X, and LinkedIn. We've got 20-ish posts on each of those at this point and growing. We're still working out how we're going to use those platforms effectively, what we're going to put on them, how often we're going to put things, and what kind of things are going to be put on there. So next thing after collecting these kind of what we call vanity metrics, right? 922 stars, 98 forks, 106 Slack members, is working on things like increasing engagement, right? So we've got this great tool that's out there and we want people to use it because we think it's beneficial. And also if more people use it, then more people might contribute to it and then it will get even better for everybody, right? That's all one of the nice little side effects of this process. And working on health metrics. So as I said at the beginning, I'm a reformed technical account manager, and I'm a bit of a geek for looking at processes and figuring out where they are and how to make them better. And one part of that is checking on the health of them. So some early plans are getting more folks into community meetings, getting more contributors, getting more people talking about KGB. There's a link here to our documentation. You can see some of the recent presentations which are featuring KGB, and we also have, as we talked about earlier, KubeCon London's coming up. We have a lightning talk there, which has been accepted. We've got a few talks which are still submitted to the rejects conference right before, because we submitted some things and they didn't get accepted this time. And we've got I think a spot in the project pavilion there. So we're trying to have a presence at as many events as possible and keep spreading the word about this cool tool that we've got here. So a couple more little statistics. If you click on this link, you'll see that we have 80 folks who over time have contributed to the code base. They've contributed to 1,806 PRs, 32 releases, and there are 6 active maintainers. So I think those are some pretty nice numbers for a project of this size. Roadmap and goals. So this is kind of where we've been at this point. Yuri made the first commit. You can go take a look in November of 2019. So that's a little over 5 years now. I think Yuri did the sandbox presentation in March of 21. I think maybe it was actually April 1st of 21. We don't have that recording, so unfortunately we can't show it to you. I know you'd all love to see it, but the latest release came about 3 months ago, and we filed this incubation application about 3 months ago as well. So latest commit is from this month, and we're hoping for 1.0 right around KubeCon. We'd like to announce a 1.0 at KubeCon and that we're officially incubating at KubeCon. That would be a really nice thing to do. So that's part of our plan. Part of the 1.0 release, again, if you click on this link, you'll go to the roadmap and you can see all of the tickets that are there and which ones are planned for 1.0, 1.1, etc. Is to have Google Cloud DNS support, gateway API support, right? Because Ingress is going the way of the dinosaur in favor of gateway API. So we're supporting that. That's mostly written already. It's just a matter of some testing and making sure that everything's tightened up before it goes into the main code base. And we're gonna, as time goes on, right? This is always something we're doing, but for 1.0, really a big focus on making sure that the reference architectures are modernized and updated, and that the documentation is revamped. I think the documentation's pretty good. There was a recent chat loop back off episode, and I think the person who presented that is on the call here today, which was great. And he walked through. He did a nice demo and he walked through the documentation, and it's clear from his presentation that the documentation's pretty good. But you always have to be trying to make things better and maybe cleaning it up. So that's one of the things we're also going to do for 1.0. So why do we want to become an incubating project? So we talked about this a little bit at the beginning, but basically we think that becoming an incubating project will demonstrate that the project is mature, that it's technically sound, that it's adopted by the community. It'll increase trust in the reliability and sustainability of the project. And it will enhance the visibility within the ecosystem. So we'll get more interest from folks, from contributors, from enterprises. And that will position us for greater impact within the cloud native community. So more people using, more people contributing, a better solution altogether. Just it's a nice little positive feedback loop that we're interested in. So.
Yeah, so before I jump into technical stuff, we really want to thank our small but strong community members. So we have a very cool flow. So for example, Pedro, who represents Millennium BCP, is both public adopters and actually contributors to the code base, right? And we had a co-speaking experience with Nuna, who also leading the KGB adoption stuff in Millennium BCP. We have Andrew, who originally from Open Systems, who was adopter, then contributor, and eventually he became a super active maintainer to the project. So like, thanks Andrew for joining and all your PRs. We have supporters like Gerardo, who ran recent Chatloop Backoff and covered project in a very nice session. So thanks a lot, everybody, for joining. And Adina, I recall we met in one of the KubeCons, right, around Crossplane booth. So thanks a lot for joining. Yeah. Let's jump into technical stuff. And if anything is unclear, feel free to interrupt me. I will be happy to answer any contextual question. So I prefer to reason about KGB from like any project from outside in approach. First, discuss what it's actually capable of, right? And some form of deployment model. A set of functionality, right? As Bradley already mentioned, we deploy KGB right to the workload Kubernetes clusters. So in this example, we have three geographically dispersed Kubernetes clusters that are deployed across different regions, right? So to enable these global traffic management capabilities, we deploy KGB project, KGB controller to each of them. So we don't have any form of single point of failure, no control cluster. Everything is distributed by design. When we have this setup, so in this set of examples, we have three clusters, but it's just to demonstrate that we can support 2+. So minimum 2 is actually one of the most frequent configuration, and 2, 3, and more. Everything is supported. We don't have any limitations, architectural limitations in a number of clusters. So when everything is configured and the KGB is working on the cluster fleet, we can apply a set of GSLB strategies that are currently supported by the project. So initially, we implemented round robin and failover, two most popular strategies. Round robin enables you to roughly equally steer the traffic across the geographical locations. So people use it for kind of horizontal scaling in a global manner, right? So like kind of application redundancy across the global locations. Next popular and probably actually like it's the most popular strategy is a failover because it's predictable, right? So this failover strategy, we can pin specific geographical tag, specific geographical location. And in this example, primary geographical location is US, so United States cluster. And whenever, for some reason, application is down in this cluster, the traffic is going to be steered to the secondary ones, in this example, Europe and China. And this way, basically for client, in case of downtime, for customer of your application, everything will be working. And that's main use case, like a high availability. But we also noticed that people use it for kind of maintenance mode. So they can temporarily manually switch the primary geotech or scale the stuff down, make some maintenance on a primary cluster and steers the traffic back. So they also using it for actual like a traffic management and some form of blue-green deployment, A/B testing, this kind of stuff, but on a global manner. The next phase of strategies that we implemented in the project is a little bit more advanced. So it's like a weighted round robin. You can assign percentages for a global traffic steering. So it's like a little bit more predictable version of original round robin. And probably most advanced one is GOAP. It's steering the client to the closest location. And this location can be backed by, decided by a GOP database. So we're using this MaxMind DB GOP database format, and you can generate it. We have example in a project where basically you can just get the one that is freely available, that has information about geographical allocation of IP addresses, and you can slice by countries, continents, and different set of geographical location, or you can generate totally custom one that will work in your data center, for example. So everything is flexible. For this one, the only dependency is EDM0 extension in your DNS environment. So that's roughly like two main things that we support, and it proved to be useful for our adopters. As you might imagine, there's kind of amount of moving parts and automation to make these things working. And luckily, everything is abstracted with a single GSLB CRD, as we mentioned before. So this customer source kind GSLB, it's basically, it's an interface for an application for a person who packages the Helm chart, if to simplify the stuff. So basically, if you have your Helm chart with your standard application deployment service and templates, you can just extend it with a GSLB kind and deploy it on a KGB enabled cluster and control GSLB strategy for your application. So in this setup, it's one of the huge benefits of the project that you don't need to rely on a centralized network team or even centralized platform team anymore. You offload the actual control of GSLB behavior to people, to the teams that control the application deployment. So it creates this nice layout and API self-service kind of on-demand approach. And obviously this CR is nicely GitHubsified, so you can put into any GitHub's configuration repo and roll it out with modern DevOps strategies. Historically, we were focusing on ingress only. Recently, thanks to Andre, we also support the Istio virtual service as a networking resource that we can reference and get the application health transitively from, and also hostname configuration. And the important stanza of configuration is actual strategy, right? That's where we can define these types that we already discussed and some additional parameters like primary geographical text. And geotags are fully freestyle, right? So you can apply whatever you like AWS style text, Azure ones, or your internal data center notation. What is actually a main component that enables this machinery? It's a well-known core DNS. So we ship core DNS as a part of the project. It's out of cluster, like a part of deployment of a KGB deployment core DNS pod that serves as dynamically crafted DNS responses according to the application health and the strategy. We also ship integrated external DNS that's to talk with upstream DNS and configure the zone delegation. So after the zone delegation, clients are going to be steered with the DNS request to these core DNS pods that are under our control. And last but not least, the main KGB controller that coordinates the logic and glues all the pieces together. So more into that diagram. So here we have two clusters as example, region I, region B, and as I mentioned, the geographical text can be totally freestyle. And roughly how it works, like assuming our clients are requesting application.example.com in DNS, they naturally contact some upstream DNS, right? An authoritative zone. They ask in upstream DNS, and thanks to zone delegation that was already pre-configured by KGB through external DNS integration, they're going to be steered to the set of to one of core DNS pods that also under control of the KGB deployment. And core DNS is going to read through DNS endpoint custom resources that is getting populated by controller with DNS records, like air records where to steer the traffic. And this set of records is controlled by the GSLB strategy and application health. So KGB is aware of application workload status through ingress transitively to service and the service endpoint array, right? So if service endpoint array is length is equal 0, meaning like all the pods are actually not working behind the service, then we treat this application as unhealthy and steer the traffic somewhere else. So it's pretty straightforward. So we are building on top of standard Kubernetes machinery. Last but not least, important functionality is that these KGB controllers that are deployed to different clusters, they actually cross-polling each other on each reconciliation loop, and they are aware of each other application status, and it enables them to actually provide a consistent DNS answer, DNS response with these core DNS instances. So they are aware of each other, and that's how actually failover is done. So how the primary and secondary is getting decided. So they acting as a consistent distributed system. So that's roughly for the design. For the integration, as I mentioned, so the point of integration is upstream DNS like Route 53 Azure etc. is this external DNS that is configuring its own delegation in an automated manner. So it is kind of out of the box experience. The important, and we support AWS, Azure, NS1. Infoblox was one of the first data center that we used in APSA. Cloudflare and RFC 2136 is actually a nice interface DDNS to hook in with a classic bind or Windows DNS. Important part on this integration is that you can actually use KGB without even if there is no direct out of the box integration, because it's enough to configure its own delegation, like a pair of NS record and GUI records point to your KGB enabled for DNS endpoints, and everything will work for you. It will be less dynamic, but it will unblock adoption. That's actually how Millennium BCP were deploying KGB before we added Azure support, full-fledged Azure support. So that's important part, that this is nice to have, great integration, but it's not limiting project deployment. We are operating on top of any CNCF conforming Kubernetes cluster with integration with classic ingress, EC2 virtual service, and gateway API, something that on our roadmap, as Bradley mentioned. And it enables us, because we are as environment agnostic as possible, it enables us to operate on-prem, in cloud, and even mixed hybrid scenarios. So no limits there, as we rely on a battle-tested DNS protocol. So yeah, that's probably it for technical part. I will be happy to answer any questions.